0413, April 9, 2026, right now marks 2,311 hours of progress on the global heart simulation. Currently, a hybrid algorithm has been created to solve the problem of managing both fast and precise line of sight calculations from a eye in 3D space towards thousands of voxels simultaneously. So what the new system does is an extension of what some of the previous methods were doing. The fastest method that was found was, instead of having a voxel calculate all of the childs that would overlap its path from the eye to voxels behind it, it was found that it's much quicker to just have an individual voxel find the voxel that is closer towards the eye from its ray pointing to the eye, just cut that ray short and then find the next voxel. And so that method was quite fast, but the problem with that method is that there was sort of angular drift, as each voxel is sort of a different angle towards the eye, and so if an angle of a voxel back here detects the voxel in front as blocking it, but then that voxel has a different parent, and that parent is sort of, it causes a sort of drift, which eventually leads to unnatural looking line of sight. And what this new system does is use rays. Every voxel has a ray, and then that ray is subdivided into points. Now, the actual having every voxel have a ray and then subdividing into points is quite inefficient, as some of the previous examples demonstrated, but this new system is able to overcome the inefficiency of calculating rays for every voxel by merging rays as they get closer towards the eye. And so, as an example, the voxels that are basically to the exact left or right of the eye, so over here, it would calculate a ray shooting towards the eye and then subdivide that into points, but the ray that is exactly beside that would have a lot of overlap in those points. And so what was done is to basically subdivide the rays into nodes, and instead of the voxels finding the parent, the ray point or ray node finds its parent, and that allows for far more efficient and precise calculation of the line of sight. And as an example of how the algorithm is able to determine the blocking of line of sight, the algorithm starts at the front of the grid, the center front, and then sort of expands outward. And so the intention going forward is to actually look up the objects to flag voxels as blocked, and then test out how fast the algorithm is in determining precise line of sight, as currently what's only been done is just generating the necessary data structure and sorting of voxels in order to be able to quickly traverse them. So the intention going forward is to test the actual line of sight blocking by flagging voxels in real time and seeing how it performs